there's a real divide between those of us who do satellite remote sensing, others that do aerial photography and aerial data capture, and then others that do drone based data capture. And I think I've never really understood why now we aren't coming together within the sector to merge all of those data sets together.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. Today I'm going to be talking to Alistair Graham, Dr. Alistair Graham, and he's got over 20 years experience in the remote sensing Earth observation industry, and he's come along today to share a few ideas and opinions about what's happening in the industry and what it might look like in the future. Just before we dive into the interview, I want to remind you that this podcast is sponsored by Hive Mapper. That's Hive as in Beehive Mapper. And this is the platform that lets you turn video footage into a 3D geospatial layer. So this is a really interesting idea. They use a variety of cameras and platforms. You upload your video film and they automatically attempt to convert it into a 3D layer and georeference it. Okay, on with the interview. Hey Alistair, thanks so much for joining me on the podcast today. If I look at your website, it says that you are an environmental consultant and you're specialized in remote sensing and image processing. Maybe before we jump into the conversation about remote sensing and image processing, if you could just give us, or give the listeners, I should say, a little bit more background about you and how you got involved in this sector.
Okay, thanks very much, Daniel, for having me on the podcast. Really looking forward to having a chat about Earth observation and remote sensing. I suppose I got into Earth observation, remote sensing, call it what you will, back in 1987. So if you were in the UK at that time, you would probably know that there was a really large winter storm that hit, and it was one of the largest we'd had for a long time. And it basically took out a whole load of woodland, caused all sorts of damage to housing and things like that. So it was a real big deal over here. And I was in school at the time over in West Wales. And again, just to orientate people, basically all of the storms that come in the winter usually hit Wales first. So everyone over there was bracing themselves ready for this thing coming in. And we were lucky enough that we had a download dish on the top of our school, which had been funded by European Union, and we had a little green screen monitor, and every couple of minutes, one line on this green screen monitor would fill in, and after 30 minutes, you would have a satellite image of sort of Wales, Western England, a little bit of France, and a whole load of the Atlantic Ocean. And so I spent probably more time than I should have done sat in front of this little green screen monitor watching one line at a time as this storm moved in towards the UK. And it was really that got me hooked on remote sensing. Just the ability to be able to monitor the weather and how it was changing and see what was coming. Really, I don't know what it was. I mean, I was already really into geography at the time, but something just clicked in my brain. It was like, oh my God, being able to see this is brilliant. Yeah, so I took it from there. I went to university planning to become a climatologist and just look at climate data. But again, someone showed me a synthetic aperture radar image of part of Niger in Africa, and it was unlike anything I've ever seen. So that again just captured my imagination, and I had to understand more about what the imagery was. And so it's really simple starts, I suppose. It's just seeing images that mean something, or that really got me questioning what it was that I was looking at. And it meant that I went through university, MSc, PhD, and a whole host of sort of postdocs, and then into various different jobs and things, wanting to use the imagery in a way that really helped people understand what it was that was happening at whatever site they were looking at. And I think that's the beauty of satellite remote sensing, is that most of the time, if you can get through the cloud and things, then you can see your site and you can start to put it into some sort of wider context, and particularly a temporal context. And yeah, I mean, for the majority of my career, I suppose, and training, we've always been wanting more and more data. And now, in the last sort of 4 or 5 years, we're in this amazing, lucky position where we're being absolutely swamped by the amount of Earth observation data, satellite data, drone data that's being created, and that we now have to find new tools to deal with, which in itself is really exciting. We're able to look at them in different dimensions and look at quality of data and time series of data. And so there's just so much happening at the moment that, yeah, I mean, everybody I think who I speak to is really excited about Earth observation. So about 6 years ago, I decided, right, in order to fulfill my enthusiasm for remote sensing and Earth observation, I'd set up my own independent consultancy, and that's what I do now. Is I basically take a lot of open data, but not just open satellite data, a lot of open source tools, and process up for different clients different types of imagery, and it's been an absolute blast. It's really great to be able to handle these data and these amazing open source software tools as well, and just help people understand their site and understand what's happening in the world, which, as we see at the moment, is really important.
I think I can relate to a little bit of your story there. I remember being at university myself and completely fascinated by how much information could be in an image. I was used to seeing images as RGB colors that would represent the world. A picture of a
Yeah,
house. I'd never thought of images as containing so much information, especially when we talk about Earth orbiting satellites. I mean, the wealth of information is just incredible. I mean, of course, you have to
yeah.
know how to get that information out, and it's really, really fascinating.
Well, this is something that I find almost perplexing, because you're right. There's tons of data in a single image, particularly if it's a multi-band image. So you've got even more information in different sort of spectral dimensions, and usually people will just use that image or a series of images for a site to look at one specific thing. And I understand why, but effectively you're throwing away all of the rest of the data. And I'm still waiting for some. I don't know whether it would be an application or whether it would be a business or an organization, but something that takes, say, I don't know, a high resolution satellite imagery or a high resolution aerial image, and almost goes through thematic area by thematic area, pulling out all of the different information that's in a single image. It would be fascinating to know how much different types of information you could get out, from sort of tree cover right the way through to area of rooftops, to the number of lights that are on the streets. Yeah, I don't know. One day I will write a program that tries to do this, maybe.
Well, when you do, please make it open source and send it and send it to me, because I would love to try it out. Hey, I want to touch on something that you said earlier when you were
Yeah.
introducing yourself, and that was you talked about this wealth of data that's available, and you talked about it as being a very positive thing, and I'm sure it is. But for me, it's almost like we're drowning in data now. And recently on the podcast, I've been talking to a few people that have been heavily involved in machine learning and AI. And I guess this has been one response to all this data, to these different data collection platforms we have, is to get the machines to do it. And that sort of leads me to the question. We have data at such a humongous scale, and we have machine learning, which is getting better and better. We have artificial intelligence, which is getting better and better, more and more sophisticated and able to solve more and more problems. Is remote sensing as we know it, as for people that were trained at university, started out as geographers, is that remote sensing dead?
um, it's not dead, but we are definitely having to move fast to keep up with what's happening in the machine learning AI sphere. I think that there's a really good opportunity for crossover, and you see it in certain companies coming out of the US and certain parts of Europe and Australia, that companies now are beginning to use some of the deep learning techniques and make them specific for Earth observation. So back in, when was it, February, I went to a conference called Big Data from Space, which was a European Space Agency conference. And that was really interesting in that it was the first time that I'd really come across a whole bunch of people who were trying to address the problem of just creating the correct type of training data for some of these deep learning models. And that in itself is an entire area of academic research. And that if you went up to someone and said, "Oh, by the way, do you want to come and do a postdoc in creating a training data set?" I'm sure they would think, "Not really." But at the same time, we really need people doing this. And some of the end results, if you get the right training data, because obviously you don't want to sort of skew the results, which you can easily do by getting the wrong type of training data, then some of the results you ultimately get would be really, really cool. And to be able to point to your part in that whole process would be really, I think it would be really neat. But you're right. I suppose the difficulty really in the whole Earth observation sphere as it is at the moment is that for so many years, we've all been calling for more data and more data. And to now sort of say, oh, well, actually, we've got too much data, I think would be really churlish. And we have to really embrace the fact that there is so much data coming online. And what I'd like to see more of actually is more open data. There are so many satellite systems that are going up and collecting various different types of information, whether it's image based or other types of Earth observation remote sensing data. But really, it's only the big governmental projects that are making those data openly available. It'd be lovely if some of the commercial providers actually had routes to making their data open. So, for instance, RadarSat recently have opened up a massive part of their old archive. I think that's brilliant. More people should definitely be following that model. But again, it now presents researchers and practitioners with yet another huge, massive amount of data, and this time in the sort of radar realm. And so being able to handle that, understand it, understand the context for not just like the entire data set, but for individual sites within that, being able to understand how the tools in the workflow to process that come together is also really important. And so the way I see it is that we need to really get the machine learning side working really well, and we need to be able to communicate really well on a human level with those people who are involved in machine learning, so that all of the mistakes that we've gone through in the past, I don't know, how 40, 50, 60 years of remote sensing Earth observation, longer if you look at sort of aerial photography, those mistakes don't get reworked by a whole bunch of people coming at it from a different angle. So I think there's a lot of areas where the machine learning specialists and the remote sensing specialists and the geographers and all the other domain specialists can really come together. And we need to have some method, some platform of where we can communicate between us on different types of topics and different types of issues that we need to address, not just on a project by project basis, but just in order to get the entire process working correctly.
I think you said some really interesting things there. I just want to try and touch on a few of them. Firstly, I
Cool.
love the idea that it could be this sort of complementary way of working together. The humans could help the machines could help the humans. At least that's what I understood you say in terms of we need to make some training sets. You know, if we're going to take advantage of machine learning, if we're going to take advantage of artificial intelligence to process these huge amounts of data, and we do want to process them, we do want to extract as much knowledge out of them because it's incredibly valuable and it could help solve some of the problems that we're facing as a planet. But to do that, we need that critical piece at the start. We need accurate training sets. And I really like the idea that this could be the new speciality of the humans. If we could go in and make those, so our role becomes more specialized. We do this, the machines do that. I really like that idea. The other thing I heard you say was a call for more open data. And yeah, which we hear again and again, and I completely understand why. But I just want to ask you a question. So at the moment, in terms of geospatial, we use GPS. It's the default way of locating things on the Earth. And
Hmm.
somewhere along the line, someone paid a lot of money to put that infrastructure in space, have it orbiting the Earth, sorry. And somewhere along the line, someone said, "Hey, this is so valuable. This will add such a huge amount of value to the country, to the world, to all these different industries that we should just make it freely available." And they did. It's a global infrastructure that we can all use if we want to. Now, I realize I've probably said that in very simplified terms, but I hope you sort of get the idea.
Sure.
But could you imagine this happening with data as well? Could you imagine someone saying, "Hey, this is so valuable. I know we put a lot of money into it at the start, but it's up there now. Let's just open source the whole lot. Let's just give it away and see what people do, see what problems they can solve with it."
I would love that to happen. I think that would be amazing. So I'm not involved so much with the European Space Agency's Copernicus program and Sentinel satellites on the sort of data usage statistics and the sort of away from the science, as it were. I'm not involved on that side. I'm more of a technical user, but I would really like to see some of the statistics that I know that they've collected in terms of how much use there's been. So my understanding is that as they opened up the Copernicus data set, more and more people have used it, more and more applications have been generated. There's so much innovation happening around that. So the benefits of having the open data far outweighs, in my opinion, the amount of money that's being put into initially creating the platforms for the data collection, and obviously also now you've got all the platforms for data dissemination and storage and things like that. So personally, I would love it if data was made open. I genuinely am a believer that the more open systems are, the better the outcomes for everything. So I generally think that open data is the right way to go. Open source software is the way to go. Open communities where everyone has an input. Being able to be open as much as possible about the sort of business practices that you're involved in and things like that. I'm not really one for getting things bogged down in legalese and having restrictions in place. So I genuinely feel that if we were able to get more data providers to open up their data, even if it was only a part of their data set, it could be restricted in terms of spatial coverage or temporal coverage or whatever. But I think it would then allow the innovators to think of new ways of using those data sets and to be able to pull in those data with some of the other open data that's already available and really create things that we haven't even begun to think about at the moment. Now, there is the sort of, on the flip side of that, there is the issue, well, already there are so many different open data sets that are they being used effectively? That's one question that I don't have the answer for. And if we had more open data sets, is it a case that certain ones would get preferentially used over others? When really the correct answer to whatever the question is that you're trying to solve might be to bring in some of these lesser known open data sets. That is sort of a wider discussion that I can only see benefits in opening up data, but I also do understand the reticence that people who are paying for these systems might have. But I think ultimately there's a benefit. And ultimately, I've been working in remote sensing now for 20 odd years, something like that. And I haven't purchased either for my own use or for my clients' use. I haven't purchased an image for 5, 6, 7 years, something like that. So people want to use the open data, in part to reduce their costs, but in part because the open data that's available now, so your Landsats, your Sentinel data, and now we've got this radar sat data as well, and other data sets. So there's sort of in the UK and elsewhere, I know there are LiDAR and aerial photography data sets. They're really good, and they do help you answer the thing that you want to have answered.
Yeah, absolutely. And we've seen this in Denmark, where I live as well. A few years ago, they opened up huge volumes of data. We're talking like LiDAR coverage for the entire country. I think, please don't quote me on this, but I'm pretty sure they fly the entire length of the country every 2 years and collect LiDAR down to a 10 centimeter resolution and make it freely available. There's aerial imagery of the entire country. I think that's updated twice a year. Again, don't quote me
Okay.
on this, but it's an incredible amount of data that's freely available.
So that's amazing that you're that the aerial data is updated twice a year. I was talking to someone yesterday, and they're really interested in tree canopy health and certain diseases that happen. And they were saying, "Oh, well, can we use lidar data and aerial photography?" And I was like, "Yep, you certainly can." And then the next question was, "Well, is it openly available?" I was like, "Yep, certainly is." And then they said, "Okay, so how often is it updated?" And it's like, "Yeah, well, there's your problem. Is that in this country things are getting better, but the open data is probably only updated, at best every year, but certainly every couple of years." And that doesn't really help them answer the questions that they have. But to have your open aerial data set updated twice a year, that's amazing.
Yeah, it's fantastic. It really is. I'd like to fast forward a little bit now. So we both agree that open data is the way to go, and that all of these platforms should just make their data freely available to us that are interested in it. So let's fast forward now in 5 years. We're optimistic. So 5 years time, that's going to be the case. Are we not going to be in the same situation? Are we not just going to be drowning in data? I have yet to see a really, really, really great data portal. I think that we've got a long way to go in terms of making data, findable. Well, how are we going to solve that problem, do you think?
Okay, I can see your point about the fact that we would be drowning in even more data. But I think that there are groups that are beginning to look ahead as to how we can handle this. So there's a couple of open source projects that I'm not involved in, but I am really, really keen to see how they pan out. I think they're going to be sort of game changing um, projects in terms of how people deal with data. So certainly within the next 5 years, I would expect that these would be some form of maturity and would be being used, hopefully, as a standard. So the first one is something called STAC. So it's the Spatio-Temporal Asset Catalog. And it's been developed by a group who are trying to look at how they can create catalogs that have a standard interface but is machine readable. So that is how my understanding of that project. That is how we would be able to deal with having more and more data that's openly available. If everything was archived and indexed through this stack API, then or the stack standard, then basically it means that you can use an API to search for the data that you need to and filter out the stuff that you don't want and just use the things that you do want and then call those imagery into your platform. There's another project called OpenEO, and I think I'm right in saying this is trying to standardize the back-end API interfaces, basically. So it means that you could have a series of different infrastructures upon which maybe your stack catalogs would sit and your data would sit. And then you would have this OpenEO layer that's on the top of it that standardizes the API calls that would then go to things like Python or R or JavaScript. And so, again, it simplifies the ways in which the machines are able to interact with the data itself. And then the third project that I think is really, really exciting is something called Raster Vision, which is being developed effectively as a framework around which you can do machine learning and deep learning. And at the moment, there's a whole workflow that it takes you through. and you can apply different types of deep learning model. Now, again, I think within 5 years that's going to be so heavily developed in terms of um, which different models you have inside of that framework. But also, as we've already mentioned, you're going to get your training data improving and becoming larger and larger, and the higher the quality and the larger the training data, the more improved your output is that you get from these deep learning models. So I think with those three projects in place, and there's a whole host of other amazing open source projects that are happening as well, but with those three in place, you would be able to collate and distribute easily through an API your data sets. You would be able to interface those data sets with your day-to-day tools that you use as a data scientist. And then you would be able to extract some meaning from the data that you have. So, yeah, I really don't see there being a problem in terms of having too much open data. I think the more that we get, the more it will push us to develop tools to be able to deal with that. And I would, again, I'm slightly biased, but I would say all of the exciting changes and developments in where those tools are coming from is in the open source world.
Okay, so we've come a long way now. We started off talking about remote sensing and Earth observation. Where you explained to us how humans might fit into this picture in the future. And of course, there's a whole bunch of other ways, but that idea that we could be very, very valuable. We need specialists to make these training data sets. So now we have machines that can process huge amounts of data. We've fast forwarded in time to 5 years where everything's open. And now you've given us some tools that will be available at that time, and it will solve that problem of making data searchable and easy to use. So in that future, what problems are we going to be able to solve with this data now that it's open, it's easily accessible? What kind of things are we going to use it for?
So that is a really good question. There's been a joke in the remote sensing sector for the last 20, 30 years or so that every single piece of work that gets funded is a project-based piece of work, or not every piece, but majority is project-based, and therefore you will get some funding usually from a central funding body. You will do your little bit of research or your little bit of develop an application to answer a question. That funding finishes, and then that's it. You might write up a paper if you're in academia, but more often than not, if you're not in academia, project ends, data gets archived, move on to the next thing. And so really what we need to be able to do now is find a way of accessing these huge amounts of data that we're potentially going to get, or certainly the large amounts that we do have now, to create services that people actually want. And that's the key for me, is that people actually want. So I get a lot of people when I talk to them, they say, "Oh my God, you deal with satellites and space and yeah, you see all these things. It must be so amazing. You get to see all these different parts of the world and you can image things and you understand the geography and there's so many different things you can do." And it's like, and you go back to them and go, "Yes, and I could help you in this way, or remote sensing could help you in this way. Um, what sort of service do you want?" And they're like, "Oh, not sure." So I think really what needs to come now, certainly from the sector, is a way of being able to talk not just about the cool tech and the cool data that we deal with, but also the ways in which we can really help people with their problems. Now, there's a lot of work going on at the moment with global deforestation and wildfire monitoring, and those are two areas where being able to have global coverage and sort of regularly updated information is really helpful. So those things are sort of ongoing at the moment. I think there's some really interesting work going on at the higher latitudes. So as we have issues around sort of changing temperatures up in the polar regions, reduced ice coverage maybe, there's a lot of information that can come out of that. we don't really understand that and what the impacts would be. So there are potential research applications, but there are also potential business applications for shipping lanes or for environmental conservation areas being monitored, for trying to understand maybe what sorts of changes are happening. So not just those that are happening to the natural environment in those areas, but whether or not people are moving into them and having a much sort of larger local impact in that way. In terms of some of the other things, there's some really interesting work that's being done to try and look at how deep learning can extract information on uh, the number of different things that might be in an image. So if you have a high enough spatial resolution and a high enough temporal frequency to the imagery that you're capturing, then you can start to count things within objects within that image and then look at change over time. So I know one of the things that's been done is all of the wind turbines, for instance, in US have been counted using machine learning, deep learning models. And again, that's something you might think, well, who wants that? But you can start to look at how the change in the whole energy infrastructure might have an impact on the types of materials that you're mining, and that might then have a direct sort of impact on how the markets, the financial markets, are dealing with the cost of those raw materials that are being extracted. So I certainly see that as we move forward, it's going to be less about showing people an image and more about giving them some sort of piece of information or index or something like that they can actually start to change their business habit or their way of working around. So this whole notion of being able to provide information that has an implication back to financial markets is a really interesting one, and one I'd like to look at a little bit further. I've sort of only skim read certain things around it, but it seems like a really interesting way, particularly around this whole area of renewables and climate change and stuff like that.
So it sounds like you see an incredible amount of potential here. And I really like what you said about that. Well, what's the question? It sounds like we can answer lots of things. We have all this data available when it's easy to find and we're easy to access. So what's the question? And it feels like there's a real education piece there. It feels like there's almost a mismatch or a gap between the people that have the knowledge that can do the thing and the people that need their questions answered. And it feels like perhaps they don't talk to each other that much. Or they don't even know they exist. But it feels like we need to have some questions. We need to have people asking more questions, and then we can provide more answers. Would that be a fair statement?
Yeah, I think so. So I'm very much of the school that you need to get as many people together as you can from different areas. Everyone will have something to contribute to answering a problem. So someone will bring the question, and then others will be able to contribute different things to answer that. So just to give an example, I saw a tweet today that was talking about a post that is online, where some people, they were machine learning specialists, artificial intelligence specialists, and they'd gone to a hackathon and were ready to, I think they were looking into autonomous vehicles, that type of thing, but they wanted to use some remotely sensed data. And so they had the nub of this post was basically that they were trying to discuss the 10 things that they'd learned about using Earth observation, remote sensing data. And it was really, really interesting because a lot of the stuff that they were saying is like, oh my God, you've got to understand what the format is. There's all these things called different bands, and each band has different information in it. And it really made me think that actually they're right when they say, "Oh, remote sensing is really difficult." It is. It is pretty difficult, and it can be intimidating to people who aren't in this in the sector, in the sphere at the moment. And it would have been really useful to have someone with a remote sensing background go along to that hackathon and be able to explain the data that they were trying to use. In the same way that, again, I think a lot of us in Earth observation, remote sensing sector are technically minded, and most people are reasonably good at some form of programming, and we're quite happy to pull in some of these machine learning models and have a crack at it and see what the output is. But do we really understand what they're doing? Do we really understand what it is that we're outputting and whether that's the right answer? And so, yeah, I am a big. Um, I will definitely shout about trying to get lots of people who can input in different ways to answer a to answer a problem. Um, Certainly, when it comes down to the technical side of things, I don't think any one person can say that they know how to deal with all of the different data types that are out there. I mean, even if you were talking to someone in Earth observation, I don't think realistically they would be able to say that they understood all of the different data formats and all of the different data types that are available just in our sector. But then to add on all of the different processing methods and the different softwares that you could use to do that, we need more collaboration, definitely. And we need some way of being able to pull together this collaboration in order to really um, help push all of these technologies and the use of the data forward away from this notion of project by project basis, and much more of a sort of like, what is it that the the sort of, either on a country basis or globally, what is it that we actually want all of these data to be used for?
In my notes here, I've got one as one of the final questions. Where are the big opportunities in the remote sensing sector? But I feel like you've kind of answered that. It feels like the big opportunity is collaboration between these different sectors.
Yeah, I think so. I really do believe that. I suppose as well, the other opportunity is to, at the moment, there's there's, and I think this is historical. Um, there's a real divide between those of us who do satellite remote sensing, others that do aerial photography and aerial data capture, and then others that do drone based data capture. And I think I've never really understood why now we aren't coming together within the sector to merge all of those data sets together. I mean, there are ways of doing it, and there are people who are trying to do it, but it doesn't seem as much of a common. Uh, it doesn't seem as much of a sort of commonality as I thought it would do. Um, so I really would like, within Earth observation, I would like there to be much more sort of collaboration between all of the different groups, and you see it happening in certain parts of the world. There's definitely uh, some areas that are more into the sort of open science and open data, open software, that type of things. But also, I think we need to look, as we've been saying in this podcast, we need to look outside of the sector and really start to bring in the people who have the problems, and bring in a much wider group of people to help us answer that.
I think that's a really interesting point there, that the sector is so divided when you talk about Earth observation from satellites and from drones, and maybe even people that are collecting data from cell phones and cars and other platforms. I think that's interesting in itself that they're so divided like that. But I also think it's, if you look at the wider geospatial industry, often it's divided into remote sensing and GIS. I think that would be a pretty typical division to make.
Yeah, yeah.
And so much remote sense data is consumed in GIS, but yet we look at them as two completely separate industries. And I understand there's different skill sets involved, but you would think that they would be more related than what they are, or what they feel like anyway.
Yeah, I mean, that's another interesting sort of historical sort of divide, I suppose, that's been there for a long time, and you can add to that now. There are those uh, that program, who like come at remotely sensed data or geographic data, I suppose, from a computer science background, and then there are those of us who just use sort of desktop software in order to sort of point and click your way around a geospatial data set. And then there's another big divide between, there's the atmospheric remotely sensed community and terrestrial and marine. And again, you could draw Venn diagrams that are incredibly complex about how these all interact, and they sort of do to some degree, but it's very interesting that there are certain data formats that are used in climate science that aren't so used quite so frequently in other data in other domains like terrestrial remote sensing. And there's 3D as well is really big in sort of drone-based sectors, whereas probably not so hot in sort of some of the applications that space-based data collection is used for. So yeah, I think I'm as bad as anyone. So when I talk about Earth observation, nearly 90% of the time I'm talking about sort of medium resolution satellite-based Earth observation. But there's so many different areas, and you're right to mention the vehicle-based data collection systems, and it is amazing the way that this whole remotely sensed sector has grown over the last 10, 20 years to reduce the amount of time that it needs to collect data and to improve the quality. I think that's another thing. I mean, we could have another discussion about just the improvements of the quality of the data and how important it is to have good quality information and to understand what the quality means. So I realize I'm sort of rambling a bit now, but I get very, very excited by how things have changed, and I can only see that they've changed for the better, despite the fact that we get a bit overwhelmed now and again by the amount of data and the amount of software that's available to us.
Alistair, I really want to thank you for taking the time to talk to me today. It's been really enlightening. And also, it's just been wonderful to talk to someone who is so passionate about the industry and sees so much opportunity there. But just before I let you go, I was hoping that you could let the listeners know where they can go to learn more about you and perhaps follow along with your work.
Okay, cool. Yes. So I can give you a whole host of different things. So my business is called Jogger, and they can go to my website, which is www.jogger, which is GEOGER. .co.uk, and I'll find out more about me. I'm also a podcaster like yourself. So the Scene from Above podcast comes out every 3 weeks or so, and that is about all of the cool stuff that's happening in Earth observation at the moment. And we try to be as diverse as we can, but as we've found out on this podcast, it's difficult to cover everything. There's also a couple of other organizations I just want to quickly mention. One is the British Association of Remote Sensing Companies, which I am vice chair of, and also OSGeo UK, which promotes the use of open source, free and open source geospatial software in the UK. I mean, OSGeo is a global thing, but the UK chapter promotes that within the UK, and I'm a member of the committee there as well. So any of those, you'll be able to find some details about me.
And I just want to tell the listeners, I can highly recommend the podcast. It's fantastic.
Thank you very much.
Alistair, thanks again. Much appreciated.
That's great. Thank you, Daniel.
At the start of the episode, I talked a little bit about our sponsor, Hive Mapper. That's Hive as in Beehive Mapper. And I explained how you can upload video footage to their platform and have it automatically converted into 3D data layers. So that's really interesting in itself. But another thing that they let you do is that you can run this object detection. So you can use artificial intelligence and segment the scene that you're looking at. So this means you could say things like, show me all the buildings, show me all the roads, and show me all the trees, just as an example. So you've segmented your scene, And then you can run another algorithm against that, so change detection. So show me how these objects have changed over time. So this is all really cool stuff. And what makes it even better is, like I said before, this all happens in a web browser. So this is accessible from anywhere. So if this sounds like it's something you could be interested in, go to hivemapper.com and search for Object AI. And that's it for another episode of the Mapscaping Podcast. My name is Daniel, and I would like to remind you again this week that you are more than welcome to reach out to me on social media. You'll find some useful links in the show notes, and I would really appreciate it if you would take the time to share this with a friend. Thanks very much. We'll talk again next week. Bye.